Okay, so check it out. We were trying to figure out which of our customers would end up signing up for and becoming part of our preferred program in our fictional company here. And we have our final results back, our test results, and what we predicted. And you can see that we were able to predict in advance most of the customers that would actually take part in the program. And so there were a couple of misses, so you can see there's one there. We predicted they would not join, but they did join. And so there were a few misses, but all in all, we were very, very close. We were almost 90% in our prediction accuracy, and that is exactly what we want to use an artificial neural network for, and that's what we're going to take a look at today. I'm your host, Sean MacKenzie. Thank you for joining once again on my channel on data engineering. In this episode, we go back to our Python playlist, and we're going to take a look at artificial intelligence, and specifically we're going to build a very simple artificial neural network using Keras and the Tensorflow libraries. We're going to set up some data, we're going to train a model, and then we're going to fit that model and test it out and see how it performs using a very simple data set, and we're going to use what we do today in further episodes down the road. Let's get to it. Looking for more resources for your project? Make sure to check out the additional links in the description. Okay guys, so a fun one today. We're going to be looking at how to create a very simple artificial neural network. I'm going to create a new file from the idle shell here, and like I said, it's a mechanical walkthrough today, so we're just going to look at how to program it. There's so much theory behind this stuff, and I will include some additional links in the description if you're interested in learning that part of it. But today we want to do a practical task using artificial neural networks, and you can kind of think of this as an A to B walkthrough from the very start through having some output that you can compare and see how successful you were. And so we're going to get some libraries here. We're going to get pandas as PD. We're going to take matplotlib.pyplot, and we're going to use that for some of our outcomes at the end. It's not necessary for the actual model. But we do need Keras.models. We're going to use sequential, and Keras.layers. We're going to use the dense layers, and we'll use sklearn.metrics, confusion matrix display, and that's really going to help us to see how balanced our result was, and that's important for seeing how effective our model was. And we'll also grab the confusion_matrix so that we can set up the display. And so those are additional libraries. The main ones that we need are PD, sequential, and dense there, but you can include all of those. Now in this directory that I'm working with, we've got a test and set of data and a training set of data. The training set of data has a few hundred rows, and you can see it has a region, credit score, borrowing size, marital status, and then whether or not that customer actually took part in our preferred program. And what we're going to do today is we're going to take a look at whether we can train our model to match the testing outcomes that we have here. So these were the actual real results that happened in a smaller set, and what we're going to try and do is we're going to try and match that as close as we can, and that's really the whole point of the artificial neural network, is to try and predict or classify as close to reality as possible. And so that's what we're doing there. So we have two files. We've got one for training and one for testing. And so what the model does is it takes in all of the training data that we put in there, and it optimizes itself so that it can predict based off of what it learned, and classify in this case various rows, based off of those features that we have there. Now the features will be the 4 columns that have categorical data in them, and then the output is is the 1 column that has the preferred 1 or 0 in it, whether or not they chose to be part of the preferred program. And so we want to predict the column that has the preferred 1s and 0s in it based off of some different entries in the test set to see if we can actually predict according to what actually happens in the real world. And so what we're going to do is we're going to read those training and test data into Pandas data frames, and we're going to have that first one, train underscore data, that we're going to train our model on and fit our model, and then we're going to use the model to predict or classify what we find in the test data set. So there's our training model. You can see that's what's going to be pulled into the train underscore data. And you can see we're going to take those columns, region, borough size, marital status, and credit score, and we're going to use the preferred score to train our model to say, you know, this combination of the features makes a 1, and this combination of features makes a 0 most of the time, and there's going to be statistical sort of training that happens there, and it's going to give us an output that we can use, the model that we can use on the test underscore data set to see if we can predict accurately what actually happened in the test data. And so what we're going to do is we're going to create a new data set. We're going to call it xtrain, and we're going to use pd.getDummies, and we're going to do that for the features, the columns that have features. And basically what that's going to do is that's going to change the feature data into numbers so that the computer can work on it in a statistical way. And so we'll do that with the x underscore train. That's going to give us a data frame with our numbers all set up and ready to go, and then we'll do our y underscore train, and that's going to be the train data preferred score from the train data set, and so, or data frame. And so that's the one that we want to train toward, and so that's going to help us there. And then we'll get our x underscore test data frame, and that's going to once again convert a similar data set in composition in terms of the columns, but with different values, and it's going to also convert that one into a statistical, something that can be used inside of the model statistically. And just like we saw before there, we're also going to grab our y-test preferred score, which is what actually happened in the real world, and we can use that to compare against whatever we sort of predict with our model. And so once we have those set up, that's great. That gives us a starting point. And we're going to calculate the input dimension, which is really just the number of columns in the input set. So we're going to say it's the length of xtrain.columns is the input dimension, and then we will we're going to specify the number of neurons here, and you can think of the number of neurons as how wide the layer is going to be, and then the epochs is sort of how many times we're going to run the model over and over again, gradually getting better each time, but we can run it too many times, and that's when you overfit your model, and so it's a bit of an art form there, and then we're going to grab that sequential model, and then we're going to say model.add. We're going to add a dense layer, and then we're going to put our neurons in there for the width of our layer, and then we'll say input dim is equal to input dim, and activation is going to be RELU, which is the rectified linear unit function, and that is going to be our activation. And so from there we can add our next layer, which will be an output layer. We will have no hidden layers in this model. This is a very simple model, so we'll just have one output, and the activation will be sigmoid, which is 0 to 1 basically. So we're going to be getting some values out of our model, and we want to essentially say it's 0 or 1 because our output in our training and test data for the preferred customer is also 0 and 1, so that's pretty simple in that sense. And then once we've added our layers, we can do model.compile, and in this case we're going to use a loss function of binary cross entropy, which is well suited for an output which is 1 or 0. And we'll use the atom optimizer, and our metrics that we'll look for will be accuracy. In this case we are going to capture our history in the model, and that is enough to get us to sort of like the most simple of models, and so then we can go ahead and we can fit our model. And so a lot of people just say model.fit and they just do it, but if you capture the results of the function in a history variable, then you can use that to see how successful you were when you're actually running this later on. And so we're going to do our model fit. We're going to train using xtrain, and then the ytrain that we set up above there. We've already specified our epochs, so we can say our epochs equal to epochs. We'll say verbose equals 1, which is going to give us all kinds of feedback as it goes through each epoch. And we're going to put a validation split of 0.33 on there so that we can graph our validation in the training phase. And so that's really cool. It's a neat thing to look at for a very simple model. That 1, we might switch it back to a 0 on verbose there, but we'll see how this one goes. And so once we have our history, we fit our model, then our predictions, we're going to use that model. So we're going to say model.predict, and then we're going to predict using xtest, which is the test data set that we set up. And we want to predict the preferred 1 or 0 column, and that's sort of what we want to find. And so the output from the model is between 0 and 1, and typically what we'll do is we're going to say predictions equal to predictions greater than 0.5, and that's going to make a data frame with 1s and 0s in it. So if it's greater than 0.5, we're calling it a 1. If it's less, then we'll say 0. And so from there what we can do is we can look at the output, and in this case we'll create a data frame, and we'll put the customer ID as our first column there, so that we can match our results back to the test data set, and then we'll put our actual result, which is the preferred score, into the second column of our output. And so we can put preferred score equals predictions, and we're going to use the flatten function, which will flatten that array into one dimension so that we can have it in our column there. Okay, so we've got two columns, customer ID and preferred score. So now we've got both of those in there, and we can output that and then compare it to see how we actually did compared to the test outcomes that we reserved in our test data set. And so we're just going to use the dataframe.toCSV, so it's output.toCSV, and we'll say preferred.csv, and we'll say index equals false, so that's going to leave the index out of there. and we can then go ahead and evaluate how well we did. Once that's been spit out, we can do our own evaluation here while we still have everything in memory. So we can say scores equals model.evaluate, and then we're going to look at x test and y test, and we'll say verbose equals 0. I just want the scores, and we'll print those out in the console here in idle, and that'll give us some idea of how well we did. And so before continuing and adding some more validation, let's just run this to make sure there's no errors or anything. So that's going to kick off. Let's see. Oh, it did go. Okay, so here it's spinning through the epochs, and it's doing the calculations each time, and generally it's getting better each time it goes around. You can see the final accuracy of 86%, which is pretty good. That's very good, and it had a loss of 0.40. And those two numbers are important. That's the non-verbose version of that. You can see in the epochs, you can see near the end, it was actually getting like 93%. You can see in the numbers there, but it looks like it may have been overfitting a little bit, because when we used it on real data, and we compared it to the real data, we got 86%, which is still very good. And so one of the things that we want to do to look at our model is to also, or our results, is to also look at a confusion matrix to see how many of actual zeros in the real world were calculated as ones, and how many ones were calculated as zeros. So that we can have a little graph that shows us, how we actually did. Because in a case where you have an unbalanced data set, you may actually end up with all zeros, and you'll see, well, it was all calculated as zeros, and you can see that in the confusion matrix display very nicely. And so we're going to do CFM equals confusion matrix, and we'll put our y-test and our predictions in there, and then we'll do our display DISP equals the confusion matrix display with the function in there, and then we'll plot it, graph it, and hit F5, and that's going to start the whole thing over again. It's going to do a whole bunch of new calculations based off of the inputs that we have there, and you can see it's going through the epochs here, and then it's going to spit out a graph this time. And the graph is pretty cool because it's going to tell us the true label and the predicted label. So you can see there was 32 and 32, very even actually, and 5 and 5 both ways. And so this confusion matrix is fairly balanced, and so that helps us to understand that that generally speaking, it was predicting the way that we expected. And we can use this to go a little further. And since we did grab our history in our history variable there, we can also do some other plotting, which will make things a lot nicer to see and to understand what's happening, because we captured our results at each of our end of each of our epochs there. And so what we can do is we can go PLT. Now we're going to just specify the plot ourselves. We'll say plt.plot history.history, and we'll put accuracy in there. That was the accuracy variable. That is a nice thing that's returned, so we can actually take a look at that, put that in there, and then we're going to grab the value accuracy as well. And the value accuracy is going to give us some more information about what happened during our run here, and then we'll put a title on here. I guess we'll put a model accuracy for this particular plot, and then we'll do plt.y label. So we'll put a y label in there just to show the accuracy, and then we can put in a plt.x label, and that'll go along the bottom. So that'll be our epochs. So as the model was running, you can see how good it was doing compared as it went through each of the epochs. And so I'll put a legend in there. I'll put train and test in there so that you can sort of see the outcomes, and I'll put the location in the upper left here. So this is how you can add a little bit more information to your output, and that's going to help quite a bit. So then we can just say plt.show, and that's going to give us that graph, which is a nice one to have for our accuracy. And so if I hit F5 here, it's going to run the whole model again, and so we'll see what kind of results we get. So it's going to spin through 100 epochs, and you can tell like this was a pretty simple data set. It was really not that hard to get a good score in this data set, on this data set. And so you can see we got 86% again. There is our confusion matrix. And oh, I broke it already, so let's take a look and see what I did here. I think I can see what happened. I'm going to fix that line for value accuracy, and for the sake of time I've cut out a run that I did there that was non-verbose. You can see it up above there, and now we've got our verbose output happening again, and I fixed that line. So this time let's see if we get our graph as we would like to see it. There we go, we got 86% again. That seems to be what we're getting for this data set. And another graph popped up, so that was our confusion matrix, and here is our accuracy, and you can see it kind of went up very quickly there, and that is what accuracy looks like. And you can also see a graph on the loss that happened during training, and so I've skipped ahead here and I've just added it to the bottom with a couple of parameter changes, and I'll also change our epochs to 200 and maybe set our neurons to 50 just for a little bit of variation. There's our loss graph programming at the bottom, and I'm going to hit F5 and start this over again so you can sort of see how quickly this can go. So here we go. Now we've got 200 epochs, and you can see that it is kind of at looks like it's about 91% accurate, 92%. It's getting a little bit better, but at this point, once you sort of go over a certain number of epochs, depending on your model, you'll notice that the accuracy will be very high in training, but it may not be so high. So this time we got 33, 32, and a 5 and a 4 for ones that were not calculated correctly. But that's still pretty good, and we actually got 88% against our real data set, which is a little bit better actually. So there you go. So there's our training validation graph, and here's our model. So we've got a nice training sort of curve, which is not erratic, which you can see. So we can see that our loss is decreasing as the model progresses, and so that's actually a good thing. So we actually calculated a bit better in real life. We got 88% almost, and that is how you can sort of gauge your, some of your success in what you did. And so what you can do then is open the output that came out from the output, and then we did 2 CSV, and you can see this is what it looks like. So this is the predicted scores for our preferred customer program, and it was 88% effective almost. And so we can see, and we could actually make changes in how we spend our money on where our resources go to target those people more than others and those kinds of things. And that's a simple neural network in Python. Looking for file downloads on the material that you saw today? Make sure to check out my downloads page. The link is in the description.